Well, here we are, lesson 8-7, solving ax squared plus bx plus c. If you notice, the only difference today is there's an a there. Uh-oh, what does that even mean? Alright, now this is not too much different than before, the thing we had before with m and p. So we're going to have these m plus p numbers add up to b, and then when you multiply m and p, it adds up to now a times c. There's the difference. Now, here's our example. 5x squared minus 13x plus 6. Now, we are going to look at the fact that, just like before, this is negative, that's positive. That means both of our items down here need to be negative. You notice this time, though, I'm going to move the x over a little bit. Actually, I'm going to not do that. There we go. So we are going to have two negative parts to this, but first we need to think. I have to get two numbers, m and p, together that will give me 13 and a negative 13, and multiplied together would give me a positive 30. All right? So, let's see, 30, 30, 30. 5 and 6, okay, but negative 5 and negative 6 does not give me, that's a negative 11. Oh, it's too hard. I think it must be 3 and 10. So, negative 3, negative 10. Now, that would be negative 3x and negative 10x. So there's we're going to break this apart into negative 3x and negative 10x. All right? That's the way I think you need to look at it, is we're taking this and breaking this apart into negative 3x and negative 10x. All right? Now, the thing I want you to look at is look at each of these numbers and look at the other two numbers that we have here, the 5 and the 6. Hopefully you'll notice that these numbers go really well with the other numbers, and each one even goes best with one of them. And what I mean by that is this. If I rewrite this as 5x squared minus 10x and minus 3x plus 6, the 5 and the 10 work really well together. The negative 3 and the 6 work really well together. Now, to get to a final answer, what you have to do is you have to factor out separate things from each of them. So what I mean is you look at 5x squared and negative 10x, and is there anything that goes into both? And as a matter of fact, they both have an x, so I'm going to bring the x out and make a parentheses like this. So I'm going to bring an x out. Also, I think 5 and 10 both have 5 in them. So I'm going to factor out 5x. So if I factor out 5x out of this part, I think the only thing I would have left would be an x. And if I factor a 5x out of this, I think the only thing I would have left would be negative 2. So take a look at that. I just factored out 5x. What did they both have in common? 5x. And I took that out. I'm left with x minus 2. Now look over here and do the same thing. I think there's no x. They both don't have an x over here. But a 3 goes into both. As a matter of fact, I'm going to bring out a negative 3. I'm going to bring out a negative 3 out here. And if I take the negative 3 out there, I just have an x left there. Negative 3 times negative 2 gives me 6, positive 6. Now, hopefully you see something here. You notice that we have 5x times x minus 2 and negative 3 times x minus 2. And now you can factor that out to look like this. 5x minus 3 times x minus 2. And that is how you do that. So I want you to look over the steps here. We broke this apart to figure out what two numbers could we multiply to get the 5 times the 6. Then we arranged it so that things go well with each other. And this all should work. With the ones they're giving you, they should all work like this. Factor out the 5x, factor out the -3, and these two things should match. And if they don't, there's a step you can take with that too. Let's go to another one. Okay, so here we have 7x squared plus 29x plus 4. So I've got to think about adding up to 29 and then also multiplying to get 28. Okay, this one seems to be pretty straightforward to me. I guess we'll see how it goes. Because I'm pretty sure that the two numbers I'm going to want are 28 and 1. Alright? Now this is an interesting case because I think as I look at what they have in common, well here, let me break it apart first. So that means I'm going to take this and break it into 28 and 1. And I think if I am right, 7x squared plus 28x plus 1x plus 4. Alright? And I did that because I thought, well, I know I'm going to use 28 and 1 because 28 times 1 is 28, 28 plus 1 is 29. So I'm breaking this apart. And I thought this 28 seems like it goes better with 7 than if I would put it over here with 4. I guess we'll see how it works. If it doesn't factor out right, then I did it wrong. Okay? It kind of makes sense. So, over here, the first part, what do they have in common? I think they have 7x in common. And what I'll have left inside, x plus 4. Now, on the other side, they have nothing in common, so I'm going to factor out a 1. And that would be x plus 4. Looks like I'm going to have 7x plus 1 times x plus 4. And I think that is correct. Alright, let's do another one, see how it goes. And here's another thing to look for too sometimes that they'll throw at you. These all have something in common right away. I think they all have 2 in common. I'm going to factor a 2 out right away, and that would leave me with the 2 right there, 3x squared plus 11 minus 4. Alright, so again, if I look at it, I notice I have a negative here and a positive there. So, oh, I'm missing something though. Huh, nice. X. There we go. So I know that whatever my numbers are needs to add up to 11 and multiply to get 12. And that needs to be actually a negative 12 when I multiply. I'm going to take a wild guess that it's 12 and 1. And one of them needs to be negative. But since this is a positive, an 11, I'm pretty sure that the 1 needs to be negative. 12 and negative 1. Now let's take a look. I think it looks like I should write it like this. 3x squared plus 12 minus 1x minus 4. Alright? Why can I not remember my x's? Okay, so on this side here, 3x is what they have in common. 3x, that's going to be x plus 4. Now over here, I really want it to be x plus 4. I think if I take the negative 1 out, that should leave me with x plus 4, because negative 1 times x would be negative 1x, negative 1 times 4 would be negative 4. So it looks like our answer sort of is 3x minus 1 times x plus 4. And the only thing you need to do is remember, times 2. There you go. Hopefully this is getting through to you. Let's try another one. This is number 15 on page 513. So I pick one from the actual assignment page so you can see what it's like. And, alright, so first I'm going to look, and I notice a couple things. This is negative, that's positive. That means both of the factors are going to be negative at the end, right? Because if this is positive and that's negative, there's only one way to get that to happen. So I need to remember that I'm adding to get negative 13, and I'm multiplying to get positive 40. Right away, 8 and 5 jump out at me, because if I have negative 8 and negative 5, that would give me 40, right? All right, so let's see. Okay, I think this one looks pretty straightforward. If I do 4x squared minus 8x minus 5x plus 10. Remember, again, just breaking this apart into negative 8x, negative 5x, because now these seem to look like they go together pretty well, right? Don't want to distract you with those parentheses that shouldn't be there yet. All right, I think 4x, that's x minus 2. And if I take out the, and I'm aiming for that x minus 2 again, take out a negative 5, I'm going to get x minus 2. 4x minus 5, x minus 2, we are done, I believe. Look in the book. Can't find it. There it is. Yep, that's correct. Now, there are times, and there are there's one, a lot of them are the odd ones, where it's prime, which means you can't factor it. I'll show you one. Number 17 in the book is like that. Let's see what that looks like. Now, you really want to be careful when deciding something is prime. You really need to make sure that you've done everything right. This one, everything's positive, so both the factors will be positive. So, it needs to add up to 3 and needs to multiply to 20. And they both need to be positive. So, there's really only one way to get 3. That's 3. 2 plus 1, right, would give you 3, and 2 times 1 does not give you 20. So you're really kind of limited in this one, and that's really what you have to look at is, okay, 5 and 4, and there's no way, since everything's positive, there's no way I'm going to get it to work. I mean, we can try, but still, even when you start, there's no way that you're going to break this apart into 5x and 4x. 2x and 1x is the only thing we can do. So this one is prime. Because even if you said, well, maybe it is 2 and 1, you could do this. 5x squared plus, let's see, I'm going to do x, 1x, 2x plus 4. Because 2 goes with 4 and 5 has to go with the other one. So the only thing they would have in common was x. 5x plus 1. This one over here would be 2 times x plus 2. And you notice, nothing works. It just doesn't, you can't factor them out. So that one is prime. But be careful, make sure that it's actually prime. Now there are a couple problems on your assignment that use this model for a height of a projectile, like if you're throwing or shooting something into the air. This is the equation, and it is on page 512. So this is the height. So if you're shooting something and it's going to hit the ground, that height would be 0, but we'll have to wait and see. T is time, and T is time. V is your initial velocity, and then this H0 thing, that is the initial height. And it should make sense if you look at it, because you think about as the velocity covers a time from an initial height, you start losing height as you go. I'm going to show you 29 first, then we'll look at like number 22, which is on your assignment. 29 is about shooting a basketball, shooting a free throw. and it talks about the initial velocity of 20 feet per second. The hoop is 10 feet from the floor. That would be your initial... Oh, no, wait, that's not your initial height. 6 feet from the floor when you start. The height is 10, because that's where you want it to be when it's done. You don't want it to go all the way to the floor. You want it to be at 10 feet. So this is what you have. And the question is, how long does it stay in the air before it gets to 10 feet? All right. Now, this is a weird one, but stick with it and you'll see how it goes. So, first thing I'm going to do is take negative 16t squared plus 20t. I'm going to start making these capital T so you can see everything. And then plus 6. And that equals 10. Now, I'd really like to move the 10 over to the other side, because when you solve these equations, you want to set them equal to 0. And like on 24, 26, and 28, you want to get everything on one side so it's equal to 0. Then you can solve it. So, subtract 10 from both sides. I'm going to end up with this. Negative 16t squared plus 20t, and now minus 4. Alright? Now, it's not pleasant to have a negative in front of the first part here. It's not pleasant to have this be negative. So I'm going to do something you're allowed to do in math, which is divide both sides by negative 1. That doesn't affect the 0, so we'll still have 0, but now it equals 16t squared minus 20t plus 4. That helps because now, if you look, we need to find two numbers that will give you negative 20 and multiply to get 64. Positive 64. So, hey, if this needs to be negative and this is positive, that means they're both negative. And I'm pretty sure that we're looking at negative 16 and negative 4. And I think you can tell which one goes with which. So I'll have 16t squared minus 16t. And over here I'll have minus 4, or negative 4t plus 4. Okay? Continuing my factoring out, I'm going to end up with 16t times t minus 1 for that part. And it'd be really nice to get t minus 1 over here, which I think means I need to factor out the negative 4. And I'm going to get t and take a negative 4 out of 4, you get negative 1 left, because negative 4 times negative 1 gives you positive 4. Alright, so that's what we have so far. I'm going to move some stuff and make some room. Okay, which now leaves me with 16t minus 4 and t minus 1. Those are the factors. Now, I can set them both equal to 0. So t minus 1 equals 0, and 16t minus 4 equals 0. On this one here, if I add 4 to each side, divide by 16, I believe I'm going to get a t equals 1/4. Over here, I add 1 to each side, I get t equals 1. So, what you can figure from this is it's going to take 1 second to get to the hoop, and it will take 1/4 of a second to get back up to that initial height of 6 feet. And so the answer you want for this one is 1. Alright, now this is a very weird one. Let's look at one that's a little more straightforward on the next one. So this is number 22. It talks about a shot put, upward initial velocity of 29 feet per second, initial height of 6 feet. So that's 29t, and then initial height of 6. Ooh, nice looking 6 there. And still negative 16t squared. Alright? So let's see, how many seconds will it hit the ground? That means we want it to equal 0 when we're done. Everything's on one side. I'm going to do my magic of 16t squared minus 29t minus 6 to get the first factor positive. So it looks like we're looking at negative 29, and let's see, 6 times 16, that must be 96. So now I have to figure out, how do we multiply to get, oh, by the way, how do we get negative 96 and have the factors be 29 and negative? So that means, again, as we've done before, if this is negative and this is negative, that means something's negative, something's positive. You know, I have my suspicions about 32 times 3. 32 times 3, oops, need the pen. 32 times 3 is 96, and 32 and 3, if you subtract them, it gives you 29. Now, I think this needs to be negative because this number in the middle is negative. So, the bigger one has to be negative. Okay, I think I know where they line up. I think I'm going to end up with 16t squared, and I'm going to put minus 32t here, and I'm going to put 3t minus 6 there. So, factor out a 16t. I'm going to get t minus 2. I really want t minus 2 over here. I think I just need to factor out 3. Okay? Well, you know, I think I'm going to get 16t equals negative 3. If you saw how I jumped a step there. And over here I'm going to get t equals 2. I think I know how much time it's going to take for the shot to hit the ground. And then this would be t equals negative 3/16. So, here's what I want you to start on and see how it goes. This will be 5/13 to 5/14, numbers 10 to 38 even. Let me take a look at those, see if there's anything weird there. Not really. A lot of factoring. So you want to see what you do, and if you get stuck in any, well, you know, we'll do that and find out when I get back. The 24, 26, and 28, you're going to have two answers for each of those because you'll factor it and then set each one equal to 0. And just see how it goes. And like I said, we'll check on it when I get back next time.